Okay, so today I'd like to talk about solving two-step inequalities. This is a topic underneath inequalities in which we actually need to do two things before we actually finish. Hopefully you've already watched my video on one-step inequalities. Kind of gives you the basics. Basically what we're going to do is we're going to combine these two things. And so I like to begin by giving myself just an arrow here underneath my inequality symbol just to remind me where to place my inequalities so that I separate both the left and the right hand side. On this first problem, I've got 2x minus 3 is less than 9. What I want to do is I want to solve, which means I want to isolate the variable the x. And next to the x here is a positive 3. So this is, sorry, a negative 3. So the first thing I want to do is I want to add 3 to both sides. So whatever I do to the left, I'm going to go ahead and do to the right. Now I'm going to go ahead and give myself a nice bar here. This is going to separate both the left and the right hand side. Because I simply only added a 3, I don't need to change the inequality, and so the inequality symbol can simply stay a less than symbol. On the left hand side, I'm going to be left over with a 2x. On the right hand side, 9 plus 3 is going to give me 12. Once again, I'm going to go ahead and give myself this arrow here. My last step that I'm going to do here is I'm going to finish this up by simply dividing by 2. Because I have a 2x here, I'm going to divide by 2 on the left. I'm going to divide by 2 on the right, and that's going to allow me to be able to cancel this off. Because I divided by a positive number, there's no need to change that inequality. It's going to go ahead and stay there. On the left hand side, I'm left over with an x. On the right hand side, 12 divided by 2 is going to give me 6. Because I've been asked to both solve and graph this, I'm going to go ahead and give myself a number line over here. And once again, the 6 is going to be in the middle. And off to the left of that is going to be a 5. To the right of that is a 7. And then what I want to do is I want to use an open circle here. Because this is x is less than 6, that implies I do not include the 6. But because it is less than, I'm going to go to the left. Okay, so for my second example here, I have a very similar problem, except instead of having a positive coefficient in front of the x, this time I actually have a negative 3. So I have negative 3x minus 1 is less than or equal to 14. And so the first thing I'm going to do is I'm going to go ahead and give myself this arrow. This reminds me both to make sure that I line up my inequality, but also to make sure that whatever I do on the left hand side, I also do on the right. So I'm going to go ahead and begin by adding 1. I'm going to add 1 to the left. I'm also going to add 1 to the right. I'm going to go ahead and give myself this nice bar here to separate both the old and the new. The 1's cancel. That was the goal there. I'm going to go ahead and copy down the negative 3x. I'm also going to copy the symbol down. Nothing changed there. I simply added. And on the right hand side, 14 plus 1 is going to give me a 15. Once again, I'm going to go ahead and give myself my arrow here. And in this scenario here, I have a negative 3 in front of the x. So this time I must divide by a negative 3. Whatever I do to the left, I also must do to the right. Now, something special happened here. I divided by a negative 3. Anytime you divide by a negative number, the symbol must switch. So that less than or equal to has got to switch over to a greater than or equal to. Be very careful with that. Everything else is going to be the same. These are going to cancel. I'm going to end up with an x on the left hand side. 15 divided by negative 3 is negative 5. I've been asked to both solve and graph this, and so I can go ahead and give myself a little graph over here to the left. And I'm going to start off with a negative 5, very small. I've got a negative 6, be careful with that, and the negative numbers, and a negative 4 here. And in this scenario here, because there is an equal sign, I'm going to use the closed symbol on that. X is greater than or equal to. Greater than is going to tell me to go to the right. Okay, so for this third example here, I've got a little bit different scenario in which I actually have the x off on the right hand side. There's no worries here. I still want to start off with my arrow. This is once again reminding me that my inequality symbols must always stay on top of each other here. I'm going to begin by actually adding a 2 on both the left and the right hand side here. That's going to get rid of the 2 there. The inequality symbol stayed the same because I just simply added a 2. On the left hand side I have a 6. On the right hand side I have a 2/3 x. Now, I have a scenario here in which I actually need to get rid of a fraction, and so this is a little unique. And what I want to do is, if you remember this from solving equations, I want to multiply by the reciprocal. So the reciprocal just means I'm going to take the number and I'm going to flip it upside down. So instead of multiplying by 2/3, I'm going to multiply by 3/2. So I'm going to multiply this by 3 all over 2 on this side. I'm also going to multiply by 3 over 2 on the left-hand side. When I do that, here's my arrow signs keeping everything in line here. I am multiplying by a positive number, so my inequality does not change at all. I can actually draw a line here to separate this off. My 3 is going to cancel with the 3, and my 2 is going to cancel with the 2, and I'm simply going to be left over with an x on the right-hand side. On the left-hand side, you have to be able to handle this however you go about doing it. Now, I like to take the 6 and put it over a 1, and so I can just go ahead and multiply these fractions out now. 3 times 6 is going to give me an 18, and 2 times 1 is going to give me a 2. Lastly, I can go ahead and simplify this by simply saying that 9 is less than x. When I go ahead and graph this, I'm going to go and give myself a little graph here. I only need the number 9 is all I need. 1 to the left of that will give me an 8 and a 10. And I am going to use an open circle on this. Why do I use an open circle? Because I have a less than symbol. If there was an equal sign, I would include that, but I don't. In this scenario here, 9 is less than x. You can also think of it as x as being on the big side, and so this is going to go off to the right. Okay, so for my last example here, this looks like a simple enough inequality. Just need to be careful. I'm going to start with my arrow here. But when I do this, on the left-hand side, I'm going to subtract a 7 here. On the right-hand side, I'm also going to subtract a 7. Here's my line separating this. I simply subtracted a 7, so no need to do anything with the inequality, but simply copy it down. The reason why I subtracted that 7 was to get rid of this. On the left-hand side, I'm left over with a negative x. On the right-hand side, I have 2 minus 7, which actually is going to give me a negative 5. Be careful with those integers. Now, I have one more step that I must do here, and what you need to recognize is actually the number in front of the x is actually a negative 1. It's implied when I write negative x that that is the same as a negative 1x. And so what I must do is I must divide by a negative 1 to get rid of that. If I divide on the left, I also must divide on the right-hand side. Now, when I divide by a negative, this scenario here requires that I actually flip my inequality symbol over. Now, why did I divide by a negative 1? Because a negative divided by a negative is going to give me a positive. Those, in essence, are going to cancel, and I'm going to be left over with an x. On the right-hand side, negative 5 divided by negative 1 is going to give me a positive 5, and therefore I am finished with this. I don't have any room to graph this. I guess I could sneak one in here, but I'm not going to worry about it. I hope this helps you out with solving two-step inequalities. I hope you have a great day.